problem technique is one of the method for solving the non-linear programming problems. Okay, whether it may be linear or non-linear, we can solve these problems with the help of this DPP, that is dynamic programming technique. And in this here, the main important step is it is a sequential process. Whenever a particular problem is given, just first we have to identify how many unknown variables are there. So in that, depends on the number of unknown variables, we have to apply that number of steps. If only 2 unknown variables are there, so that problem can be solved with the help of this dynamic programming technique. Within 2 steps only we can get the solution. If there are 10 unknown variables are there, then we can solve it by 10 steps. Here steps are known as stages. The main method for solving these dynamic programming problem is, here we have Bellman's principle of optimality. Okay, I'll explain that with the slides here. See here, just first come to the introduction part. The dynamic program is a method, it is a mathematical technique of solving programming, has been used in the mathematical allocation of resources and useful for problems where the decisions are taken at several distinct stages. Stages means here different steps, such as every day or every week. The scientist Richard Bellman developed this technique in the early year of 1950 and invented its name, called as a Bellman's principle of optimality. The dynamic programming can be given a more significant name as recursive process or recursive optimization. In dynamic programming, a large problem is splitted into small subproblems, each of them involving only a few various steps or stages. Each in one variable, the optimum solution is obtained and finally completed till the final stage is reached. In this, the answer of the question is based on Bellman's principle of optimality, which is stated in the following sections. That is, the dynamic programming can be discussed in various fields. That is, discrete case, continuous case, indeterministic case, and probabilistic case model problems, and we can solve by this method. Thus, the dynamic programming method is very useful for solving various problems such as inventory model problems, replacement model problems, and to the Bellman's principle of optimality. Okay, dynamic program problem is here the long or the lengthy problem, it can be split into small problems. A very large problem can be split into small size problems, and each and every individual case we can obtain the variable values. Suppose 10 unknown variables are there. First, we have to divide that 10 unknown variable problems into 10 different stages. In each stage, we can obtain each individual variable unknown value. In first stage, we can obtain the x1 value. In second stage, x2 value. Like that, if you go up to last stage, we can obtain the 10th value, x unknown variable, x 10th variable value. That means whenever we want to find the x unknown variable, we need to calculate x n minus 1th unknown variable values first. If you know the n minus 1th unknown variable value, then we can obtain the x nth variable value. That is, if 10 variables are there, first we need to calculate x1, x2, x3 up to xn in sequential order manner. That is, in stage 1, we can get the x1 value. In stage 2, we can get the x2 value. In stage 3, x3, like that. In stage 9, x 9th value can be obtained. If all these 9 variables are obtained, then come to the last stage, x nth value can be obtained in 10th stage. That is, each stage or each steps can be divided into stages. That is, a large variable or large problem can be split into small problems. In each and every individual cases, we can obtain the variable values. Like that, the procedure can be done in this dynamic programming section. For solving the dynamic programming problem, here we have one important method, that is Bellman's principle of optimality. That is, the scientist Richard Bellman, he developed a method for solving the sequential manner problems in the year of 1956. So with his name only, the method name is called as a Bellman's principle of optimality. It means here, the problem, whenever the problem consists n unknown variables, first we have to split that large problem into a subsequence problem, that is sub stages. If n variables are there, first we have to divide that n variable problem into n different stages. In each and every individual stage, we can obtain the different values like x1, x2, that is up to xn. So the large problem can be split into some small sub problems. In each sub problem, we can obtain the individual variable values. That is, can be done in this Bellman's principle of optimality. In this Bellman's principle of optimality, we can derive a recursive formula. Like if you want to find the fn value, first we have to find the f1, f2 up to fn minus 1th values. Okay. So the principle for Bellman's principle of optimality, just I will show it. So it is also called the recursive optimization technique. This Bellman's principle of optimality is also known as, or this dynamic programming problem is also known as recursive optimization process. So the major thing is just what is problem format? It consists of object to function and subject to the constraints and non-negative condition. But whereas in general LPP, there we have taken the degree of each and every individual equation will be 1. But whereas in dynamic program problem, the degree must be either 1 or more. That is, whether it may be linear or non-linear problems. Even though it is non-linear problems, we can solve it. Okay. And with the help of these Bellman's principle of optimality only, we can find each and every individual unknown variable values. Once we can obtain the all unknown variable values, substitute that values into objective function, then that indicates whether it should be either principle of optimality here. He given one equation for solving that entire large problem into split into smallest subproblems with the help of this Bellman's principle of optimality. So the formula for Bellman's principle of optimality is given by just Right, okay. See here. Yes. So the Bellman's principle of optimality is saying the P of X comma DN. Here RDN is return return function, immediate return function. Yes. Based on we can solve each and every individual dynamic programming problem. So once again, I will repeat this equation. See here. Is Fn of x equal to maximum of dn belongs to x, or of dn plus f of n minus 1 to t of x comma dn. Here, see here. Fn of x is the optimal returns of on n stages. The optimal returns from an n stages process when the initial state is x. So Fn of x is, it is an the optimal return an stage process when the initial stage is x. And the next R of dn is immediate return due to decision dn. So R of dn means return function, immediate return due to the decision dn. And T